Hello everybody. Today we're going to be talking about Azure DevOps, and in particular how to use Azure DevOps to get traceability across all of your work items, your repositories, and your deployments. So I'm really excited to be able to dive in here a little bit with you and talk about some of those topics. This does sort of presume that you know a little bit about Azure DevOps. I plan on making a lot of videos, by the way, like this, and this. So what this is not meant to be is like a grand overview of Azure DevOps. It's not meant to go into every feature, functionality, or service provided by Azure DevOps, but really just focus on how do you work in Azure DevOps in a way that creates traceability throughout the entire system. So I'm really looking forward to jumping in here today and getting started with you. A little bit about me. So I'm a leader in the DevSecOps space, and I've been in cloud for many years. And so I've been using these tools for a long time across multiple companies, standing this up greenfield and working with existing implementations to optimize DevSecOps principles and practices, as well as GitOps and other components of modern development, and getting more features faster to happier customers with greater agility, reliability, and security. So that's really where I'm focused at. Today we're going to be primarily talking about Azure boards, Azure repos, and Azure pipelines. With that said, just a couple things that you're going to need to get started is an Azure DevOps account. And because of some recent policy changes with Microsoft on Azure DevOps, you may need to set up billing and set up an Azure subscription for this to work. Otherwise, you can wait a couple of days and submit a form that lets you be able to work with pipelines inside of Azure DevOps. So it's a recent change. It's pretty frustrating. I apologize about that, but I'll make sure to put that in the links below. With that said, please do like and subscribe and hit the bell on this if you find this content really interesting. It gives me the good vibes and makes me want to continue to make these videos so that I can teach other people how to use these tools for development. Getting started here, I just went to Google and typed in Azure DevOps. The very first thing you're going to see is Azure DevOps Services, and if you click that, it's going to bring you to the product page here for Azure DevOps. As you can see, you can start free. It is a free product, so you can have up to 5 basic users. That does not include test plans as a part of Azure DevOps, and use that absolutely free. Not a dime of your own money. So it really is an awesome platform, and I hope that this helps to demonstrate some of the cool capabilities that are in Azure DevOps. So the first thing I'm going to do is just sign into Azure DevOps with my current account. I'm going to start out by actually signing in with GitHub. So you can use your GitHub credentials to create your account and sign into Azure DevOps or to your Microsoft Azure accounts. So it's really nice how easy it is to use all these tools once you've got it set up. This is actually a project I had created previously to create a YouTube demo, but we're actually going to create a new project today. We're just going to call this My Application. Now, here you can see you have private repositories. Public repositories are grayed out. There is a setting in the organization settings that allow you to turn public repositories on, but by default, in the free tier, they're just gonna open up private repositories to you, but you can turn it on. If you expand advanced, you can choose Git version control, TFS, as I mentioned, and then you've got a couple of different work item processes. I have set my default to Agile, but by default, it would be basic. So you want to come in here and make sure that you pick the appropriate work item process that works for your team. And I won't go through this today, but you can create custom work item processes in Azure DevOps and use that on your team. So a lot of teams will have very specific requirements around the way they organize themselves in the tool and the permissions that they need to different services and the kind of process they need, like what states are the work items going to have, what kind of work items are they going to use, what are the fields that need to show up in those work items, etc. All of that is incredibly configurable within Azure DevOps. Unfortunately, it's a big topic, and I don't want to, bog us down in that. I really want to focus on how do we build a system that lets us work with CI/CD in a modern way that creates traceability across our work items. So let's go ahead and create this project. The first thing that I'll show you is the marketplace, because we're really not going to do much with the marketplace, but the key concept there is that Azure DevOps comes with these great services and offerings out of the box. This functionality can be extended. You can write your own custom marketplace extensions, or you can use other marketplace extensions that are published out on the marketplace to fill gaps in your CI/CD process or your planning or other things. There's integrations with Git repos as well. So I encourage you to take a look at all that stuff. A good way to get there is to go to the organization. So we'll go back to the organization where we can see we've created this My Application project. And if you come here, you can see the extensions option. And you can see we don't have any installed, none requested, and none shared. If I browse the marketplace, I can find all these different extensions that you can use. So for example, some good ones are like replace tokens, allows you to create tokenized variables in your code and replace those at runtime so that you can do build once, deploy anywhere type deployments. That's one way to do it. Depending on your framework, that may not be the best way, but it is an option. There is so a couple other things, like if you're doing infrastructure as code, you have things like this Terraform marketplace extension that is really great and has tasks that really help to improve your Terraform workflow. Then you have things like the AWS Toolkit. AWS Toolkit allows you to do things like run AWS shell commands or interact with S3 buckets. There's a bunch of different things in here, and you can see the whole list of things that you can do with the AWS Toolkit for Azure DevOps. Also not going to install this. We're not going to be interacting with AWS today. The point behind all of this is that this tool is extendable, it's customizable, and it plugs into multiple cloud providers. I'm going to go ahead and jump back into our organization, Justin O'Connor Codes, and go to My Application. Now, when you start to work, one of the first things that you're going to do is start to plan and describe what product you're trying to build. So if you're working in an agile situation, you might have your Scrum team that's going to deliver the work, your product owner who knows what they're trying to build. You might have a solution owner for the overall solution present. Regardless of what that is, you typically in an agile situation are going to have the backlog grooming, and then you're going to have sprint planning, your daily scrums, your sprint retrospectives, and your sprint reviews, right? And so boards is what enables you to do all of those things. So this first page you come across is just all of the items that you've most recently accessed or have most recently been updated, things that are assigned to you, stuff that might be most immediately relevant to your current work. And this is really used primarily by the folks that are out there on the Scrum team executing. You've got backlogs, and backlogs let you plan your backlog of work. So you can see there's multiple backlog levels here. Right now we're sort of features and stories. I'm going to jump up to the feature backlog and create a new work item, and you can see here that it's offering to create a new work item of the type feature, and you can add it wherever it's at, or to the bottom or to the top, whatever you like. In this case we don't have any features, but we'll just say like create checkout cart, something like that, right? We'll add that to the top, and now you'll notice that there's like a little plus symbol here, right? So you could say this is user story 1, and this is user story 2, etc., etc. And you can plan this work, collapse it, and create hierarchies. You can look at different backlog levels to see where you want to focus. And obviously because we're going to be planning this work after we've created the backlog, we're going to need something like a sprint planning activity. So there's a couple of different ways to facilitate that, but one way is to go directly from this backlog that we're on itself. So on the right hand side you can see we have iterations. Within your project settings, you are able to change some of this stuff. So you have project configurations where you can change your iterations or areas, right? So the area is like where your team maps to, and your iterations are your sprints. And so like if you really wanted to and you weren't happy with this, you could rename this like sprint 1. And you could set the start and end date to like the 21st and make the 4th here, and then save and close. And then maybe we just like delete these for now because we're not going to use these. And then we could add a new child. This is sprint 2, and the start date for this one would be the 7th. So you see it automatically picked up where the next sprint would start, which is really cool. And now it knows you're doing 2-week sprints, so it can automatically pick that up. So going from here, it's pretty easy to create all of your new sprints. So that's pretty much how you manage that. So if we go back to boards and we go back to backlogs, now we can see that we have like sprint 1 is here, and we can add a new sprint for planning and add that sprint 2 here if we really wanted to. And now we can plan our work, right? So right now, both things are currently planned for sprint 1, which we're currently in, but I just moved one of those items to sprint 2. So pretty easy to plan your work in Azure DevOps. We have like story points on here, and you can't see it because we haven't actually added any. So maybe we should, like, if we did our planning, we might have 2 on this one, and this one might have 3. So it's a good way to like facilitate DevOps hygiene and making sure that everything is up to date. Of course, you can see the state and the value aligned business area and things like that. So this is the general idea. Now, once you have a backlog set up and you kind of have these sprints worked out, so you might do multiple sprints in advance of planning, you can come to the sprint board here, and it's going to be defaulted to the current sprint always, unless you change what that is. This is one of the best places to look at the backlog for the sprint for the team. And here's where I would add in the story points. So as a part of sprint planning, you'd be like, okay, like which stories are we going to do? Who's doing them? And then over a couple sprints, you develop a velocity, and you can look at that and say, how many points can we reasonably do? And this is a really key part, I think, of Agile, where if you really want to get people out of the waterfall mindset and get them to trust your process, you have to demonstrate to them that your process works. And that means when you make a commitment, that you can deliver on that commitment. So getting really good about this is important. And a great way to do that is once you've got that velocity and once you've got these story points, you can use it as a gauge to see if somebody may be over or underutilized in a sprint. And then once you have this entire backlog built out, you can basically put it to the team member and say, okay, X team member, you have these 3 stories, they total 10 story points. That's, historically where we're typically at. Do you feel comfortable committing to this? And if not, what do we need to continue to clarify to understand? Do we need to increase the story points on something or reduce story points and make sure we get the right scope included? Those are great conversations to have with your team, but I just want to mention that this is a great place to do that backlog planning and review before going into your sprint officially. You can easily use this board to assign work items to different members of your team, and then you can use the plus buttons to do something like this where you can say, these are all the things that we would do. Generally speaking, I like to have 1 task per day's worth of work. I don't really want to necessarily put it like that, but the goal is demonstrating progress every day. I've seen too many times with companies and clients where you end up in a situation that a story stays active, and it never gets to close. And by the end of the sprint, it wasn't done. And there's no transparency as to why that was happening. I worked on it yesterday. I'm working on it today. I don't have any blockers, but then it still doesn't get done. This gives you the opportunity to demonstrate progress and where progress is being made throughout the engagement and continue to hold people accountable. So we'll go ahead and assign these out. And now you can see that we're kind of ready to kick off the sprint, right? So we're going to go into that daily Scrum cycle, and this is an awesome place for team members to come daily and move things around as they're getting their work done and showing that progress toward their overall work product. I won't talk about this too much. This goes for both sprints and for boards, but there are configuration options that you can set, like different fields, different styling rules for your cards, different backlog levels. So if you look at like the boards, you're going to see something similar where you've got these different options for configuration. Now that we've added tasks on the board, you can actually see that we have do A, do B, and you can add tasks now directly from here. So we can do C, right? So it's really handy to be able to just add things directly on the card sometimes too. So some teams tend to use this view, some teams tend to use sprint views, but whatever way you do it, whatever works for your sprint team, this is kind of how we orient ourselves in DevOps and get work assigned out and measured and communicated and ultimately done according to our commitments. So outside of just the planning and the actual execution, you have queries, and queries allow you to basically find work items that you have created. So if I wanted to go and look for all of the user stories that have been created in any state, I could run this query and see that I have 2 user stories and both are in the new state. or in any combination of a million of different other fields and content. It could be based on date, it could be based on IDs, it could be based on state, it could be based on text, like whatever's in the text. There's a lot of different ways to slice this. So you can, like as a project manager or even as a member of the team looking to better manage your work, this is a great way to sort of orient yourself toward that and to keep track of things, in addition to the work items page, which we already looked at. And the other thing is delivery plans. This is more used for executive views of maybe like feature roadmaps and how something's going to be developed more long term. Some teams will use the idea of a program increment, so maybe like a 6-week bucket, so a bucket containing 3 sprints of work, and organize features around that so that we can communicate those on sort of a quarterly basis. So this is where you start to bridge that gap between Agile and Waterfall in a way that doesn't break your Agile development process, still communicates everything, and because at the local level where you're delivering those stories, you're getting accurate and you're being consistent and you're being reliable, people trust your plans and are more willing to move from a waterfall mindset to an agile mindset. Now, with all of that set up and with that work being delivered, in the overview section here, you can always create dashboards for your project. Dashboards work by adding widgets to your board. You can create, like a burn down if you wanted to add a burn down, and you can see here we've planned some work. You could add, code tiles or a chart for work items, configure all of these different things. There's so much that you can do with these boards, but the idea is create a consistent view that works for your team, that facilitates your end goals of tracking the work properly and getting it delivered within the agreed upon timelines. And finally, you have wikis. This is a great place for doing things like your release notes. And you see a lot of larger companies tend to already have a wiki solution in place, something like an Atlassian Confluence. And those are really great when you have really large teams and you want to communicate a ton of standards and common information. There are still use cases for wikis because of the integration of these tools. It makes it really easy to mention work items or code or repositories or pipeline deployments. And you can use Markdown, which in most wiki tools you can now, but it's really well supported as a part of Azure DevOps, and it's a natural way for developers to think. So just consider where wikis might fit into your process. But that's really your work management, your documentation and tracking. The next thing is your repositories. So by default, when you create a project in DevOps, you are given a repository by the name of whatever your project is. In this case, it's my application. So you can just copy this. And like you would with any other repository, you can go to your code editor of choice. In my case, it's Visual Studio Code, which is just an absolutely fantastic tool, and I highly recommend it. If you don't already have a preference for something else, of course, anything would work. So here I'm going to go into a folder called code, and then I'm going to clone this repository using SSH. So it says that I have appeared to clone an empty repository. Perfect. So I'm going to go into my application, and actually for the sake of this demo, what I'm going to do is I'm going to open up the folder itself so that we can see any files that we create right over in the side pane here. So my application, open. We're going to add a file here. We'll just start with a readme.md. Okay, and in this file we'll just say overview and DevOps is awesome, right? Now we have a file in our get initialized local repository, and we need to make sure that we can push that up to the remote. So in this case, we're going to open up that terminal again, and we're going to do get status, and we can see we have one unstaged file. Do get add, and you can spell it out, or you could use like a dot to say commit everything in this current directory, or you could use star, and any combination of different patterns to get all the files committed. But in this case, we just have one, so it's pretty straightforward. Get status, okay. We're going to commit this, and we're just going to say initial commit, and we will get push. Now when we type get push, you'll notice that what we just did was we pushed from local main to remote main. So we directly pushed code into our repository without a pull request, without any kind of review. That's obviously not a great practice when you start thinking about a really complex application that's running in production that runs business critical workloads. You need a really good process around this. So this is where I get excited and where things are going to get really fun with this presentation, because we're going to start going through how we can set up our system for developers to be able to work in a modern way. So we're going to go to the repository again. This time we're going to look at commits just so we can see, well, if we go back to files first, you can see our README file is here and you can see the documentation. And you can also see the history. There's an initial commit. You can also see that same history inside of commits. And pushes is a similar view, but it shows you like all of the commits that are a part of a push, which could be really interesting. And it's also broken up by date. So just another useful view. And then I'm going to skip over branches for a second and look at tags. So tags is a great way to just version code in your repository. And we won't cover it in this. I will do a separate video, but you can use things like git version to automatically add tags whenever you merge good code with master, that kind of thing. And then we have pull request. And this is where a pull request will show up once we create one. So since we haven't created one, and let's go ahead and do this first. So this is our branches. It'll have a list of your main or master branch, whatever your trunk branches, and then all of the other branches that get pushed to this remote. So that could be all of the development, branches, feature branches, dev branches, things like that you might have. If you go into the branch policies, this is where you can configure some best practices. So for example, it's a best practice to require a minimum number of reviewers to ensure that there is good code review that would facilitate a higher quality of the overall final product. You want to generally not allow requesters to approve their own changes. That prevents any individual actor from pushing code to master that could become a candidate for promotion to production. Prohibit the most recent pusher from approving their own changes. That's a great setting, right? In general, when you're working with teams, because you don't want that person to, even if they didn't initialize this repository or push this branch, you don't want them to be able to approve the code if they made the changes themselves. I'm going to uncheck that for now because I'm the only person in this project and I will need to be able to approve my own changes. And then I never check really this allow completion, even if other viewers vote or to wait or reject. It's all or nothing, right? The approvers are the approvers, and if they approve, then you can merge, and if you can't, you have to resolve the comments. So with that said, it's good to add this feature here that says check for comment resolution and make that required so that people have to respond to comments that you have. And then when new changes are pushed, I like to check this and say that require at least one approval on the last iteration. That's one way to do it. I typically like to reset all approval votes and restart the entire review and approval process so that everybody has a chance to react to all of the new code that's been pushed. So we'll keep that in there. We're gonna make the minimum number of reviewers 1 for now because I'm the only person in this project. And then check for linked worked items. This is really good if you want to make sure that people aren't working on things that are not tied to feature development. So in general, this is the best practice to say, like, if you're working on something, it should be in a user story and it should be tracked and it should be a part of your overall velocity. That way you don't degrade your ability to actually measure the effort that's going into each sprint. I'm not going to turn it on for this because I won't have a user story for every one of these pushes, but let's just go ahead and keep it here for now. And then you can limit the merge types. Some teams prefer to only have certain types of merges. In this case, I'm not going to basically enact any kind of such restriction. But those are some best practices around policies on main. And some of the even better practices probably are around automating the testing of the code that's getting pushed to master so you can get to trunk-based development. And when I say trunk-based development, I mean that you don't have long-lived dev branches and long-lived feature branches and release branches. You have the trunk, which is like main or master, and everybody is doing micro features. It's like you're constantly raising or creating a branch, writing a little bit of code and merging it with master, creating releases, deploying those to production. So the changes are smaller, they can move faster, they're easier to review and easier to approve, and they're easier to roll back, right? So as you get into this scenario where you want to deploy faster and faster and faster, a way to help to enable that is to make your changes smaller. But to do that, you can't just rely on human reviews for these things either. You need some sort of automated testing. Linting is always great to have, where you can make sure your code is of high quality. Security scanning to make sure that you're always keeping your configuration secure. open source scanning to make sure that all the open source tools you're using are okay to be used, so you're not getting yourself into a situation where you have to release your code to the public or you can't monetize your product. Just keep all of those things in mind as you are going through this process. But we're going to actually see in this demonstration how you can set up build validation. We won't have all the tests, but you can see in principle the way that works. And I'll do a separate video entirely on writing tests for approvals in these pipelines. Status checks are good too. You can actually hit like pretty much any like API that integrates with Azure DevOps and have it do a status check. So there's a lot of different ways to configure this. We won't really be talking about that today, but that is a useful way of making sure you have good code. And then automatically included reviewers. Now this is something that you do want in an organization where you have a more formal change management process, and you want to be able to demonstrate like there's some core group of people that for some reason have the skills or the experience or the organizational knowledge to be core approvers on a repository. So you'll see a lot of companies have like a pull request review board or something like that must approve these things, and that could be one of those approvers, right? So if you're in a smaller company where everything's really agile and everybody's kind of just doing their thing and you kind of trust each other to peer program, this might be enough. But if you need that additional assurance and that additional set of eyes and that knowledge that certain people have looked at something, you can enable this. And so let's actually do that really fast. The best practice around that is always use groups. Never directly assign anybody to any permission within Azure DevOps. So the way we do that is we go to permissions in our project settings and go to groups, create a group, and we'll just call this pull request approvers. And click create. Now inside of this pull request approvers bucket, I'm the only person in this organization, so I'm going to go to members and click on add and add myself as the person who can review and approve things. And now we'll go back to repos and branches and branch policies. Oops. Branch policies, and we will add in this group of required approvers. So in this case, it says add people, but you can also add in, for example, these pull request reviewers. So pull request approvers for my application, and we'll make it required, at least one of the reviewers. And in this case, I will have to allow requesters to approve their own changes because I'm the only person in this project. All right, so now we have this group configured to be automatically included in any pull request. So let's kind of put this to the test now, right? So we're going to go to our code again, and we're going to create a file, and we're going to call this deploy.py. And we're just going to create some pseudo code here just to demonstrate the pipelines process and stuff like that. So we're going to import sys. We're going to set in a variable called environment, which is going to be equal to sys.argv, and this is going to be the first argument passed after the actual file path. And then we're going to just print here something with an F string that says code deployed to whatever environment that might be, right? So this is going to be the environment. So you can see here that right now we have this new file. We are still in the main branch, and we are up to date with what's in the main branch currently. So all of that's good. But let's try to like push this, right? So git add, git commit -m, and we're going to say add deploy file and git push. This time, it did not let us push to main because of the requirements that we have set that say that we are not allowed to push directly to main. You have to create a feature branch. So all that's the policies we just created on the repository. So what we have to do here now is say, okay, well, I'm going to do git checkout -b, and this is going to be my feature. All right. And then now we can do git push, and we have to create the remote branch. So we're mapping our local to the remote, my feature mapped to my feature. And when we go back to DevOps and we go to our repos, you can see here at the top that it says I updated this just now, and it's going to automatically give me this option to create a pull request. When I do that, you can see here that it's saying add deploy file and all that kind of stuff. So this is great. One thing you notice is that you can link work items here by hand. So you can come in and click and add work items. You can add reviewers if you'd like, and you can add tags, which can be used for automation purposes or for organization of your code. But something that we don't see here is like the ability to automatically tag a user story. So let's go look at our work, and let's say I was working on user story 2. And I can see here that this is ID number 10, user story number 10, user story 10. So if I come back to my code and let's just say, let's say test user story mapping, and we'll do git add, git commit -m. And now if we do a # and then 10 and say updated readme and git push, those changes are going to get pushed to our remote. And we go back to repos and we have the same option to create a pull request, but this time you can see that the work item is actually linked here. So we're just going to put deploy file. I would always do a much better job of describing my changes, but this is just like pseudocode. So we can see our deploy file, we can see readme, we can see that there were 2 commits. We're going to go ahead and create that. So now you can see that comments must be resolved, and that pass is checked. So this is one of the required checks that we implemented as a part of our policies. But it says a member of the pull request approvers must approve. And I happen to be a member of that group. So I am able to go ahead and click approve. You can see now I could complete this. So now I have this file that is basically in there that I can use for a pipeline. So I'm going to show that we could deploy, this code to a pipeline. But what's a pipeline? So let's dive into that. So you can see there's this cute little robot and a dog pulling on its tire and a dude on his laptop. They're all working on a rocket ship together. This is where you pretty much first land to create your first pipelines. By clicking this button, it's going to take you into a GUI-based sort of like wizard that lets you get things started up. One thing you can do is say, I want to create my pipeline using YAML. You can use a classic editor, which is a GUI-based editor. I highly don't recommend that. So philosophically, I would say the approach is everything is code. So you should be looking at how you can put all of your configuration in code as much as possible. Now you're going to see us break that paradigm when we go to use releases, because releases is the GUI-based version of release management on the CI/CD platform, Azure DevOps. But there's good reasons to do that. It's just more feature rich. There's certain features in YAML-based pipelines that are not available that are available in releases today. So currently, I still haven't been able to fully convince myself to go to fully unified YAML pipelines for everything that I do, in particular where there's a complex approval workflow or something like that. But it is possible to create all of your pipelines, and the GUI output of those coded pipelines is actually really, really nice. But for now, what we want to prove is that we can publish an artifact of code that can be consumed by a release and deployed to an environment. And when I say an environment, we're just going to have pseudocode that prints the text that we had, which is the code is being deployed to whatever environment. So I'm going to initialize this with my application, and you can see here I have a couple different choices. It recognized that the code I'm using is Python, so it's recommending something like this. What I'm going to do though is go to a starter pipeline, and you can see here there's some just basic pseudocode, right? I can try to save and run this. When I do, it's going to give me an option to do a commit or raise a pull request. So I have to raise a pull request because we have the branch policies. So I'm going to save and run that. It's going to create the pull request and push the branch and everything like that, which gives it the ability to actually run this pipeline. And you'll see this just get started here. Well, while it's, we can wait. Looks like it's going to go pretty quick. So here's the one-line script that prints hello world. And here's the multi-line script that adds other tasks to the build, right? So, and then you see this link here. And that's just the code that was inside of the pipeline that we just raised the pull request for. So if I go to repos and pull request, you can see here that it automatically created this pull request, and the code is this pipeline, the starter pipeline that we created. I'm going to go ahead and approve that and complete it, complete the merge. And then I'm going to come back over my pipeline here, or sorry, my code in VS Code. I'm going to git checkout main, and I'm going to git pull. so that we get that file over here on the left-hand side. And you can see now we have triggers, which are like what do you want to trigger this pipeline? You can set it up on a schedule, like a cron job. There's a bunch of configurations, and I'm not going to go over YAML in this video. I'll make a totally other video about how to create YAML-based pipelines and do some more complex things with stages and jobs and tasks. But in this case, we're just going to create a very simple task that publishes an artifact. You can see here it's using the Microsoft hosted agent on the Ubuntu latest. And what we want to do really is kind of just gut this entire thing, right? And we're going to create our own step, and this step is going to publish artifacts to Azure DevOps so that they can be used in a release pipeline. So a good way to find this is you can just type in, Azure DevOps and then publish artifact. Now there's an old way of doing this and a new way. If you come to the docs that first pop up, you'll notice that there's a purple note here that says this task is deprecated. We recommend using this new pipeline artifacts task. And this is what you should be using. So you can see this is the step that you want to run. And we'll go back to VS Code. We'll update this. And we're going to say, okay, so we want to publish the code that's currently in the system default working directory, which is the default directory. And this is just a variable within Azure DevOps. So again, I'm going to do a video on this separately. You can come out here and type in Azure DevOps variables. And you can see classic release and artifact variables. Here it has a list of all of the different variables that you can reference. And just from a syntax perspective, so you're aware, anytime you see a $sign and like an open parenthesis, this is where you can use your own personal variables that you define in your YAML file, or any of the default variables that come shipped with the pipeline itself. And in this case, what do we want to publish? We wanted to publish deploy.py. So imagine we're in this machine and there's a directory and it has all the files that you see on the left, but all we really care about is deploy.py. And we're going to put this artifact just in a folder called code. We're going to do get status, get add, get commit. I need to actually create a feature branch. So get checkout-b feature publish artifact. Okay, and get status, get commit-m updated YAML file, get push. This is where we start to get into CI/CD and how to actually do CI/CD correctly. So hopefully you've seen some of the best practices around configuration of the branches, and now we're going to look at configuration of automating the continuous integration and continuous deployment. So if I go to my pull request now, you can see that I have this new branch that I've created, and I can go ahead and create this. And for now, I'm going to go ahead and I could run this just to test it before I do anything else, just to show that it works in its new state. So we could run this pipeline. We have to run it from the feature branch that we currently have. But what we should see is that it's actually able to take the code from the main branch and create an artifact that gets published that can be used in a release, which we're going to see in just a moment. And I'm mainly running this to make sure that there's not some syntax error or like some code issue before I merge it with master, because master is king. So you can see it published the pipeline artifact. And if I go back here, you can see that it actually says there's one work item related to this, and there's one artifact published, and it's in a thing called code. And you can see that the file is deploy.py. So it ignored all the other files and it just brought this one file up. Awesome. So now we feel good about merging this. So I'm going to go ahead and do that. I'm going to approve it, and I'm going to complete it. So let's take a step back on this. So right now we're just publishing an artifact. But before you publish that artifact, normally in here you might have your, your code linting, security scanning, unit testing, whatever it is that you want to do to ensure quality. So if you think about the development process, what we ultimately want to happen is we want the human review to be sort of that top level review, but we want to make sure that a lot of this stuff gets caught programmatically without us needing to really see it ourselves. So like, did they use snake case? Did that feature break when they wrote this code? I can't go validate this, especially as systems grow and these applications become bigger. Without automated testing, you don't know if what's going to master is good and what's going to get shipped to production is going to break something. So it's really important that we create this upstream process of requiring these steps to run before things get into the master branch. So we could write some pseudocode for that, but I think the point is well taken, that we want to be able to run all this as a part of our pull request process. So how do we actually do that? Well, you go to your branches, you go to your main branch, branch policies, and we briefly touched on this, but here's where we're going to do build validation. So when you hit plus, it's going to look for all the builds that you have, and you can select the one that you want. You can filter it down to certain files and paths if you only want it triggered under certain situations. Like maybe you don't care if when the README is updated that this actually runs. So just think about that in terms of your code and the way that it's structured. We want this to automatically run, and we want it to be required. That way nobody can merge any code with master that doesn't pass all of our tests, our code coverage, our security requirements, our code linting, code quality pieces of our process. So now we want to push some more code, and this time we want to see that the pipeline runs automatically, and then we'll create a release. Actually, before we do that, let's go ahead and create the release, because we do have an artifact, and then we'll show the end-to-end CI/CD configuration of all of these things. So let's go to pipelines again. And in pipelines, you have this concept of environments. You don't have to create environments. These work pretty well when you're using YAML-based deployments and you want to create environments in your YAML file where you need an approver involved. I'm not going to get into that because we're not using this today, but I'll do that in other videos where we're doing YAML-based pipelines. And here you have releases, and this is really where we want to focus ourselves a little bit, and this is where we're going to create our pipeline. So let's create a new pipeline. And you kind of got the option to like choose one of these featured or other starter templates, which can be really useful, and they encompass a lot of generic use cases. In this case, I just want to use an empty job. And you'll see here over to the left that you have the ability to add an artifact. And so here's where we select the artifact from our project, and the artifact that's being published is called my application. And you can see that it gives it a source alias of like my application, right? But you could make this whatever you wanted to be. You could just make this like artifact and add. So now you can see the name of this artifact is called artifact, and this is where that code bundle that we put together is sent. Now in terms of CI/CD, so there's a couple of things to consider. So first, on the artifact, there's this little continuous deployment trigger. This is the CD part. So you can choose to enable this trigger to create a new release every time there's a new build available, which we'll do. But we'll say that we only want it to run when the code is coming from the main branch. And similarly, we can set it up that a pull request trigger turns this on. And again, we'll say that we only want this to run if the target branch is the main branch. So when we raise a pull request against the main branch, then we want this particular stage to run. So now we've got some CD configured. And then here again, you see like a person and a lightning bolt. This is where you configure your approvers and your triggers for deployments and gates and other settings around your CD process. So here we can turn on artifact filters again, where we say like, I only want to be able to deploy here if it's from the main branch. And we might say that we want this to run on a schedule, which we don't in this case, and we want to enable pull request deployments. And finally, maybe we want to add a pull request deployment approver to this. And in this case, actually, let's not do that. Let's create two environments first. I think that would be a better way to show this. So here's our agent job that runs in the stage that we have. So let's modify this stage and call it development. And let's come here to the agent job, and we're going to add what's called a task. And in this case, we want to run a Python script. So there's a convenient task out here for running a Python script. If we select that, we want to give it the script path. So in this case, similar to what we had before, we could do the system default working directory, and then slash whatever the artifact is. In this case, it's artifact. And inside of that, we have a folder called code. And inside of code, we have deploy.py. And it accepts an argument. And in this case, it's the environment that we're deploying to. So we're going to call this development. And we will, that should be good enough for us here. So let's go back to the pipeline and finish configuring this. So now you may want approvers here. So it's a best practice to use groups as well for this. So I'm going to uncheck this for now. We'll add approvers to the production stage. So I'm going to come back to here actually. I'm going to remove this artifact filter for now. And now what we're going to see is we have this process where we can raise a pull request. It automatically runs all of our checks and generates the artifact. And then assuming all of that's successful, we'll automatically trigger our release to deploy our code to an environment. So fingers crossed, I just did a lot of things and hopefully I didn't skip a step that's gonna mess us up. But let's go ahead and give this a shot. So I'm just gonna save this with these codes. So git status, git add, git commit -m, added comments, git push. So now we can go to pull request and we'll see that we have the ability to create a pull request here. I'm going to create that pull request. And because we've enabled this automated process where the build is going to be built that's running all of our tests, now if these tests don't pass, if this pipeline fails, we will not be able to approve and merge this code with our master branch. So this is really an important step between the pull request approvers and between the settings that we have on our branch and the build validation that we have. These are some really great ways to ensure you have high quality across your entire DevOps system. And as you can tell, that check passed. So if I open this link in a new tab, we can see that the job ran and that it created the pipeline artifact. Nice. All right. And next thing we want to do is go to the pipelines, the releases. So here you can see it automatically created a release that's to be deployed to develop. And in this case, it did not deploy it because this artifact is coming from the pull request, like the non-main branch, right? So the actual artifact underneath this is not coming from main. So we only want it to deploy if it was merged into master in this case. Now we could force it by just deploying it. So we're gonna go ahead and do that to make sure that the code in this stage is actually correct. But now when we actually merge this pull request, what we're going to see is a new release will be created and then it will deploy all the way without any kind of manual deployment. And that's where we get that continuous delivery of our code being shipped to different environments within Azure DevOps and within our cloud platforms. So you can see this succeeded. And if we go to run Python script, you can see code deployed to development. Awesome. So everything worked with our script just the way that we expected it to. The next thing that we would want to do here is edit this pipeline and potentially add another stage. An easy way to do that is just to clone it. And we're going to call this production. And now we can configure some more things here. So we didn't want approvers on this stage, but maybe on production, we do want approvers, right? So I'm going to go ahead and save this for now. I'm going to go to project settings. I'm going to go to permissions. In groups, we're going to create a new group called production approvers. Create, and we're going to add my account as a member of production approvers. And we will go back to our pipeline, our release. We'll edit this, and we're going to come to run this Python script. And in this case, for the production task, we want to put production in here. It's the same artifact, so build once, deploy anywhere is the general DevOps principle here, which is that we have one artifact that goes to all of the environments so that we don't change anything about the way that things are configured. We just pass different variables to these different configurations in order to do things differently in the different environments. But this limits drift and makes sure that our code can be consistent and that features are well tested and the things that we expected are what we expect to happen actually do happen. So now we've got a production stage, and for the production stage, we probably want to make sure that we have the pre-deployment approvals enabled. And here we're going to have production approvers from our My Application project. We'll put a timeout of 3 days. And we'll say that normally you'd want to say that the user requesting the release or deployment should not approve it. That way you can't have a single bad actor deploy bad code into production. It takes 2 sets of eyes. In this case, I'm the only person, so I will not set that setting. But we'll go ahead and save that. And now what we'll do is go ahead to our repository and our pull request, and we are going to go to that pull request and approve it. Since everything passed, we were able to approve it. And you can see that even in here that the release was successful, right? So we didn't rename our release pipeline. We probably should have. But this is basically saying like, yeah, not only was the build successful, but the release was successful as well. And now when we complete this and complete the merge, what we're gonna see is that we'll go to pipelines. You can see that this is queued and is ready to get started. Currently, there are no, if you click in here, there are no, maybe it's already done. Yeah, it already published the artifacts. Okay, I was trying to get there beforehand, but anyway, you can see that it did publish an artifact, and that artifact has exactly what we expect. It has the code deploy. Now, because of so that's our CI done, and our CD has been triggered, and we now have a development stage and a production stage. If we open this release, we can actually watch this run through. So let's just give it a moment. We look at dev and we can see that this code was deployed to development. And now production is waiting on a human being to approve it. Again, normally I would have it set so I could not approve this, but because of the situation that I'm in, I will approve it. You can deploy for later as well, and this is where it's important to set the correct time zone within your organizational settings. So right now it's set for Eastern time, so I know that I can, whatever time I set it for is going to be the actual correct time based on where I'm at. In this case, I want to go ahead and approve this and not defer the deployment at all. And finally, we'll watch this run for the production stage. The last thing that I would mention in this particular tutorial, and again, there's going to be others where I go in much more detail about some of these topics, about DevOps and DevSecOps and best principles and practices, and how to use this tool to facilitate these automated systems that enable you to do more deployments more quickly in a more secure way. But there are these things called library groups and secure files. I won't cover secure files, but just know it's a place where you can upload files securely, encrypted and transited at rest, and you cannot retrieve those files, but you can use them in your pipelines. And similarly, variable groups are a place you can store variables for use in your pipelines. And these are great when you talk about teams at scale where you have tons of different projects, but you have a similar set of maybe environments and you want to use a similar set of variables, and you don't want multiple people to have to pass those variables themselves. So here I'm just going to create a development variables, and we'll add one. We'll call this environment, and we'll call this one development. And by the way, you can actually lock these down so that they're secret. Nobody knows what they are, and they can't unlock them once they're locked and saved. But for now, we're just going to make this a plain text deal here. And then we're going to clone this one more time and just call this production. And the environment is going to be production. And I'm just going to copy this thing. Okay, so save. The next thing that I want to do with this is go to our pipelines themselves and go into the releases and edit this. And we want to link our library variable groups. So right now we don't have any variable groups assigned. So under the variable section, under the pipeline variables, there's variable groups. You can link a group and then align it with a stage. So in this case, I want these to be the variables for my development environment. And I want to link as well the production ones and align those to my production environment. Okay, cool. So now we have those variables. And similar to what we saw in the YAML file, you can use those inside of your script. So instead of the arguments being here like this, I could do this and put environment. And similarly in production, I can make this just environment and save, add library variable groups. Okay. And now what we will do is create another release. And what this is going to demonstrate, and actually before we do that, there's one other thing I want to show you. Under the options, you can do integrations, and you can report deployment status to boards and to work, right? So you can choose like how you want this stuff to be posted out. So I can map my development and production environments to these different variables and then create a release. And once you've done that, what this will actually do is report status back to this user story. So you can see where all of the deployment and pull requests and everything were automatically appended to this work item. And similarly, up here in the upper right-hand corner, you can see all of the release details based on the code that was pushed through to the pipeline right here. So you can see the success of those deployments in the user story where the acceptance criteria and everything is defined. So it's an incredible system for being able to see everything in one place. Going back to pipelines briefly and looking at releases, we can see now that these are deploying successfully. I'm going to go ahead and approve this and look at the logs in the Python script, and boom, code has been deployed to development. So even though I'm using library variable groups and I'm substituting a variable, you can still get all the same values here. And so if you extrapolate this to more complex situations where you have huge environments with a bunch of variables that you need to use across multiple teams in a standard way, library variable groups are an awesome best practice for doing that and also securing some of those secrets. And if you're using Azure, linking your key vaults to library variable groups is another great way to keep your secrets secure and also be able to rotate them on a regular basis without breaking your CI/CD. With that said, I really enjoyed this overview. I hope that you found this beneficial and that it taught you something about how you can use DevOps, boards, repos, and pipelines in a way that leverages best practices for continuous integration, continuous deployment to get to a model where you can deploy more features faster to your customers in a way that is agile and that is secure, that's repeatable, predictable, and makes working in these types of environments so much more fun. And this is a small project, but the real benefit to this is you start to scale this across your enterprise and your organization, and you see these benefits 10 and 20 and 100-fold as you start to get more and more complex, because this really simplifies a lot of those concepts. So if you like this, please do not forget to subscribe, hit the bell, like this video, and it encourages me to create more content like this. If you want to see something deeper in any of these topics, I'm more than happy to do it. Just let me know what you'd like to see next. Thanks so much.